Good evening, everybody. Welcome to tonight's edition of the Triangle Area SQL Server User Group's main meeting. And tonight we have with us Deb Melkin, who's going to talk to us about data integrity. So please take it away.
All right. Well, first I want to say thank you all so much for having me. I'm really excited to be here. I love talking about this. So we're talking tonight, data integrity demystified. So for those of you who don't know me, this is me. I've been working as a DBA for over 20 years. I mainly work with SQL Server, but I've done enough with a couple of the other relational databases, just enough so I can do some damage. I also mainly work with transactional systems, although I've done a little bit with warehouses and data marts, just enough so I can do some damage. I'm a board member of the New England SQL Server User Group, and that is the local SQL user group here in the greater Boston area. It's actually, I think, one of the oldest user groups in the nation, so it's actually kind of cool. But we host user groups like this and do all of those sort of fun things. So I get to help out whenever they need. I am a data platform community speaker. I've spoken here, other events throughout with the data platform community. I'm an IDERA ACE class of 2020. So thank you to IDERA for having this sort of program. I won Speaker Idol at the last in-person PASS Summit. So I'm the reigning Speaker Idol winner. And I will take that bragging rights as far as I can go, which probably isn't much further, but I was still pretty honored that I won that. And the last thing was back in November, I was awarded the Microsoft MVP for Data Platform, which I'm still very quite humbled by, and I'm definitely very honored by that. This is, by the way, the unimportant stuff about me. The important stuff you need to know. I am the alto section leader of my choir. We are looking forward to being vaccinated and being able to sing together in person. We're like chomping at the bit. We're so excited. I attend bluegrass jams regularly. I've actually been able to go to a couple recently. It's amazing. I've been learning guitar and mandolin as part of that. I reframed my camera so you can't see them over here. And the other thing is I'm a musical theater geek. I'm not as geeky as a lot of people I know, but I still can throw a picture of me and Bernadette Peters after seeing her in a Stephen Sondheim show. So, just because it's very exciting. So that's the important stuff to know about me. But that's probably not why you're here. You want to talk about data integrity. And, so we're going to talk about a couple things. We're going to break it down this way. First, we're going to talk about setting the foundation. Then we're going to talk about designing for our data. And then, of course, we're going to talk a little bit about data integrity and performance, because they're not necessarily the same thing, but they definitely work together. And I think it's important to note how these different things can affect performance. If you have questions, make sure you put those in the chat. I'm going to have several times where I can ask Kevin if anyone has any questions. So please feel free to put those in there, so I know you're here and you're following along, and this all makes sense to you as well. So let's just jump right in. So I like starting with definitions because, it's a good place to start, especially when we start talking about things like data integrity. It sounds really lofty. So let's kind of break it down and let's look at some of the definitions. So for integrity, I went to the dictionary. And according to Merriam-Webster, there are a couple of different ways you can interpret this. Firm adherence to a code of especially moral or artistic values, not quite what we're looking for, but I think this definition number 3 really fits. The quality or state of being complete or undivided. I think when we're talking about databases and our data, that's probably something to really think about. An unimpaired condition could be as well, but I like the quality or state of being complete, because I think that really is what we're trying to achieve. Now, if we were to look up data integrity, so here I went to Wikipedia. The maintenance of and the assurance of the accuracy and consistency of data over the entire life cycle, and is a critical aspect to the design, implementation, and usage of any system which stores, processes, or retrieves data. I really like this definition for a couple of reasons. When we're talking about data over its entire life cycle, because we don't always think about it, but there's definitely a life cycle to our data. How long do we keep it? When do we add it? When do we update it? How do we move it around? It grows. Our data grows. Our databases grow, and everything that it means changes or It can change depending on what we're doing and how we're setting it up. And so data integrity is really about thinking about that data over the entire life cycle and understanding how do we implement it and making sure that we can enforce it and support it, really. I think support's probably a better word. However we use our system is really key to what we do as data professionals. But what it really comes down to, for me, if you had to say what data integrity is, it comes down to this. So I have a value in a cell. What is this? And data integrity is all about making sure that whatever that one stands for stays what it stands for. As long as it's in that cell, in that field, in that column, this is what this represents. And really making sure that we can protect that and support that and keep the consistency of that is really what we're trying to achieve with data integrity. So I usually save this sort of thing towards the end, but I think it's really important to think about it from the start, because why does this matter? Why are we going to spend all of this time thinking about this? Well, first, you have the garbage in, garbage out rule. If your data is garbage, everything you're doing with it is going to be pretty much garbage. You can't do much with it. And that leads to, can you trust your data? If your data has no integrity, can you trust it? You're dealing with garbage. So you're going to have to do all these other sorts of things because you don't trust your data. And our data is not living by itself. I had the example of that one field in that one table. Well, there's a lot more to it, because think about it. There are probably other columns on that same table. And we start expanding it out, we really see that it's not just by itself. And then this is my favorite one. Our data is accessed by multiple sources. I love it when someone comes to me and says, oh, we don't need to worry about it. Only the application is going to be touching the database, or only our application is going to be dealing with this. And usually my response is, well, okay, but how do we deploy our changes to our databases? We don't do that through the app. So it's a simple way to remind there's more than one ways that we access our data in our database. And we need to make sure however that data gets accessed, they're all reading the data and they're all interpreting data the same way. And we're all making sure that no matter who's accessing it, we're ensuring that the data is good. Whoops. And the last thing is, if we think about all of this stuff, we tend to solve problems before they happen. And that's the best thing, right? We can avoid certain issues because we've already ensured that everything's in place so we have integrity. So now let's start setting the foundation. So how do we build data integrity? A lot of the things I'm going to talk about are things that we probably deal with on a day-to-day basis, but I want to start thinking about them not from how we use them day to day, but kind of thinking of what they mean for the larger picture of our data and our databases. But like I said, we're going to start with the foundation. So where do we start building data integrity? With how we're storing the data and the different data engines that we're using. So the first things that we think about are relational databases. This is a Microsoft data platform. A lot of times we're dealing with relational databases, SQL Server, Azure SQL. It's the first thing we're going to try using to form our data so we can know how we're creating that data integrity. And of course, that means we got to think about NoSQL databases, stuff like Mongo or Cosmos DB. And we can build it from there to data lakes. It's how we're storing our data, right? Excel. And I'm going to put the caveat here. I'm not saying Excel is a database. I'm saying we store data in Excel. And it is something that we use because as we're thinking about where we're starting with, how are we defining our data, where we're starting that, the fact that our data lives in Excel does matter. Even if it's in a text file, it's still data in a text file. And we need to understand where that data is storing, and that's giving us a starting place. So that way, as we build out from there, regardless of where it is, we can start applying those concepts of integrity to wherever the data lives. Because now we can start doing things like thinking about naming conventions. These are hills that people are willing to die on, right? These are things like people are very passionate about how you're supposed to name things, whether it's what sort of capitalization and punctuation. And punctuation usually I mean underscores. Character limits. If you have a database that needs to be hosted on multiple different relational database systems, for a while, Oracle still had that 30 character limit, even though SQL Server blew past it, many versions ago. But you still had to write keeping those in mind. Singular or plural table names. That's another big point of contention. Three-letter aliases. I think now that people use schemas more, it's not as much of an issue, but that is part of a naming convention. How are we logically grouping our objects together? What sort of prefixes do we want for our tables? And it's funny, there is a reason why we want to spend so much time thinking about our naming conventions. I'm definitely someone who likes looking at a brand new database and going, "Ooh, I know what this is," not there are no vowels and I have no clue on how to interpret what that name is. Or I've seen some names in my time. Let's just put it that way. But because I'm partly a visual person, and I think a lot of people are, they want to look at a table and understand it. So let's kind of think about what that means, right? So we're starting with things like camel cases or lowercase or underscore between words. And so a lot of this is, how do we look at the name? How do we read it? This one, I don't have a particular stance on, just as long as we're kind of consistent. All lowercase I just find is hard to read personally, but if that's your standard and you're sticking to it, that's the important thing, I think. Um, then you have stuff like supercalifragilisticexpialidocious is 34 characters long versus long nonsense word. I mean, we've got all the characters. We could technically use them, but think about how you're using this, that top one, supercalifragilisticexpialidocious. We'll start referring that to the Mary Poppins table. And that's probably why we want to really make sure we name things appropriately, because what does it mean? That's why I like long nonsense word, because I think it does a better job of describing what's in the table. And I can look at that table and have a pretty good idea of the type of data I'm going to be storing. So it's going to be clear what data goes into that table. And then you have this singular versus plural, gadget versus gadgets, plural. For this one, I do align with the camp that likes the singular name. And I like it because we use our table names in sentences when we refer to things. I have one record in my gadget table. I have one record in my gadgets table. That can work. But then you can have things like, I have one gadget record. I have 5 gadget records versus I have one gadgets record, 5 gadgets records. I'm kind of over enunciating the S at the end, but you can feel a little bit of awkwardness when you describe it when their table name is plural. That's my personal preference. But again, you got to be consistent with whatever you do. And the reason why is you can end up tables like this one. And I may or may not have been part of creating tables like this. I mean, I don't think I always push the different naming conventions that go along, but it's great because then you can start saying, oh, right, so this was the release 24279.8 where we changed to all camel case. So, but you're adding new columns and there were already columns on the table. And it's great because then you get a history of your naming convention throughout your database and you can do those sort of funky things. The problem is then it's, well, what do I've got a new column to add. How do I name it? What am I going to do to make sure it's consistent so anyone looking at this table understands what things are and knows how to modify it going forward, how to make additions and expand it if they need to. So again, the thing is you really want to make sure you're clear with your names because again, it's the first thing that we do to figure out what's on the table and what everything means, what your table what your table is storing, as well as what should go into that column. So this is how I'm thinking foundations and how we create those integrities on that level. One, we're defining the structure of the data in a sense. We're giving it that first thing. Where is it stored? So we kind of understand the type of data. Our data is in a relational database. Our data is in a text file. This is why naming conventions so important, because we can look at those names and easily understand what the data represents just by looking at it. It's great. It limits the confusion and can really make sure that we're storing what's supposed to be stored there. And so by creating that consistency and that structure, we can now start defining what's in our database. And creating those definitions that we can all use is really crucial to having a good database design and really making sure that that's where it is creating the foundation of our data integrity. So, are there any questions yet on that as I take a sip of water?
No questions yet. Looks like there was some discussion in chat. Oh, there is a question, but there was some discussion in chat about naming standards. And Andrew says, "My naming standards, it makes sense."
That's a good one. It should always
so,
make sense.
Hopefully so. So,
Yes.
what tools do you like and why when it comes to defining data models?
My basic data modeling tool that I use if I create data models, and actually that's what you'll see different examples that I've been doing. I use ER Studio. It is by Adira, and it's just coincidence that whole Adira ACE and liking ER Studio. I like it because I think it does a good way of creating a data model. I like the way that I can work with it. I think it's just a clean tool, but there's so many out there. I think there are some which even are free as well. So they kind of run the gamut. So whatever works best so you can understand what it is definitely go to one to use, one to look for. ER Studio or Irwin's another one that a lot of people like as well. So I hope that answers that question.
Yes, thank you.
Okay, great.
Oh, there's one more question here.
Sure.
You may get to this, but how would you enforce the nomenclature or other design principles?
That's a great question. Um, I think some of it is you just have to set up standards in your company and you need to make sure that they're clearly defined and everyone helps you enforce it. When you make changes, hopefully you have a review process, and part of the review process is, did you name this properly? If you are using a modeling tool, there are ways to enforce domain designs and to say, hey, go through and change all of my uh, keys so this is how you name them. They'll have macros that are involved. So ER Studio definitely has some. So there may be some ways that depending on how you're making these changes and how you're creating the table designs, you'll be able to do it that way. So there are lots of different ways. But again, the biggest thing is setting it so everyone kind of has a good way to work through it and review and you have to have buy-in too to make sure everyone's following it as well. So that's a really good question.
Yeah. So, tracking changes, how do you manage those?
Um, in terms of what, I'm not sure I understand that question.
So you had the example of refactoring over time, where if you follow different standards with the schema changes, you may have underscores in some and camel case in others, and so how do you manage the schema changes?
That one's hard. I mean, again, hopefully you don't make too many changes, like big changes like underscores versus camel cases. Um, it, I don't know if there's a good way. I hate saying that, but it's just something you have to watch out for. Hopefully, you can try to restrict them and really say, why am I making these major naming convention changes? There could be some which it's hard though because then you have things that affect um, everything else depending on how ingrained those naming conventions are. Stuff like if I've seen stuff where people have had data types as part of the name or something like that, or you have that table or TBL as part of your table name, which a lot of people don't like either. Or um, you want to try to minimize them and really make sure that if you're going to implement changes for naming conventions, that you try to make them as minimal as possible and really make sure that they make sense. It's hard. I don't know if there's a really good way, especially if you're dealing with a legacy system, because there's just going to be too much stuff that's referencing the old name. So um, I don't know if there's a good way for that, unfortunately.
Okay, fair enough. Looks like that is all the questions for now.
Okay, those are great questions. So now let's talk about designing for the data. So there are a couple types of integrity we're going to talk about. And this is where we're going to get the nitty and gritty of dealing with database design. And again, a lot of this stuff we do all the time, but let's start thinking about it from a different perspective. I love doing that because I appreciate these things much more. So the different type of integrities. First, we're going to talk about entity integrity. So it's what are we doing to maintain integrity on a table level? Referential integrity. So we're talking about relationships between tables. And then we're going to talk about domain integrity. So domain is dealing with the columns. So we're going to deal with our columns. So thinking about, I kind of have an entity, an attribute in parentheses. So that gets into the logical idea of designs versus a logical versus a physical design. And so a lot of this is going to apply on the logical side of things. We're going to, a lot of ways we implement, there are physical implementations, but in many ways we will think about certain things from a logical perspective as well. So let's start with entity integrity. So we're going to start with database design. Whether it's what type of relational database design are we going with? And it's funny, this is probably not part of the traditional piece of entity integrity if you were to look it up, but I feel like it's really important because the first thing we have to know about our tables is, are we designing in the normal forms, or are we doing star schema, right? Because that matters of how we're going to do everything else. That's the first thing that we're designing. So we're talking about how are we grouping our data together, creating that logical way of putting things, of organizing our data. So now we can start providing that additional meaning based on a column's role on the table. Because remember, when we're talking about normal forms, we think the key, the whole key, nothing but the key. So all the other columns, if it's not part of the key, the primary key, they're all defining the primary key. If we think star schema and we have a fact table, we have to understand which are our foreign keys to dimension tables and which are our measures and weights that help define, or that are, the measures and weights for those different, um, uh, oh my gosh, I just lost the word. Dimensions, that's the word I'm thinking about. Wow, it's been a long day. So, but again, the roles of the columns are going to play are based on what type of database design we're doing, what relational database design we're going with. Because this all is going to start coming up with our primary key and what makes up our primary key, the fundamental of our table. So for the definition purposes, because as I said, I like definitions, you have the column or combination of columns that define the uniqueness of each record on the table. Again, column or combination of columns. All columns must be not null. You can only have one primary key per table. And again, this is where we start thinking about what a logical primary key is and versus a physical primary key. Because again, depending on what we do, that there may be a difference between them. It depends on how you're designing your databases. We'll come back to that idea in a little bit. So I like this tip for defining a primary key. And I use this all the time. I'd have developers come to me and give me a new table and say, okay, Deborah, I have this table, and I say, okay, something's missing. We're missing our primary key. And this is a question that I used, and it was a really great idea and a great way for us to figure out what's the primary key of our table. So it's saying, what does this table hold using one or two sentences? And I think it's a really good way. Not only can we define our table well, but it really starts pointing us to the column or columns that define what that is. So we're going to start with this gadget order form. So if you had to ask me what I'd say a gadget order form is, I would say it's an order for a person, for a given corporation, for a certain gadget on a given date. So if these four columns pretty much make up what I think defines my gadget order form. So now that's my primary key on my table. But again, it's a good way to say, is this what makes it's not just what makes each record unique, but it's really defining the heart of what that table is. We can't talk about a primary key without talking about a surrogate primary key. And I kind of feel like I have a little bit of a soapbox with surrogate primary keys. It's not that I don't like them, but I think we forget how to use them properly. So back to our definitions. So if you look this up in the dictionary, there are a couple different definitions for surrogate, and I think surrogate's a key word here. One that serves as a substitute. And I think when we talk about surrogate primary keys, I think a lot of people don't always understand what a surrogate primary key is. They just say it's a primary key, but not understanding it's a surrogate primary key. Because we do this a lot. Oftentimes we'll take an identity column, throw it on a table, say, here's my primary key. Look, everything's unique and we don't have to worry about anything. But it's by itself, it's meaningless. Think about what we just talked about with the primary key. What defines that table, right? What is that table about in one or two sentences? A random ID column doesn't quite do it. So for me, if you were to ask the questions, do surrogate primary keys create integrity? No. Will they make each record unique? Yes, but they don't create that integrity. Because think about it. I had this order form and I said these 4 columns are what this table is about. It's what makes each record unique. But if I just put an identity column on here, well, I don't help create that uniqueness for my table. So I'm not against a surrogate primary key. Again, and I think sometimes you really do have a hard time finding out what makes a table unique, or you can say it's these columns, but you can't make that combination unique for a multitude of reasons. I do believe there are some exceptions, but here's the thing with surrogate keys. I like the saying, if you stand for nothing, you will fall for anything. I like adapting it for surrogate primary keys. If your surrogate primary key stands for nothing, your data integrity will fall. It will fail because you don't have anything that really helps enforce what you have. Again, I'm not saying don't use surrogate primary keys, but we got to think about making sure that those columns which are supposed to be unique, that would otherwise be your primary key, your logical primary key, we want to enforce those. We want to create something to help enforce that uniqueness. Luckily, we have a really easy way to do that. Our unique key constraint, right? So if you have to use surrogate primary keys, take what was supposed to be your primary key and you can make that a unique constraint because it's so similar to a primary key. It's that column or combinations of columns that create a unique set in addition to your primary key. It's also not as strict as a primary key because you can have null columns in part of your unique constraint. And it also helps you allow to have that multiple unique combinations because there could be multiple things that make the columns on your each record unique. If you have every different combination, you may start having issues, but again, it's nice to know that there are multiple ways. That's why you can have a surrogate primary key and a unique constraint. So a great question would be, what's the difference between a unique key and a unique index? Because those two pretty much work the same. Kendra Little has a great blog post about this, and I have the reference at the end of this deck. So I will be able to share that and you'll be able to look that up. But she had really 2 key things about that. One, the use of filtered indexes. So you can't do that with a unique key constraint, but you can do that with a unique index. So maybe you're doing soft deletes. So you want to keep everything unique based on your active records. A filtered index would be a way to do that. The other thing is where we start getting into kind of the performance part of things is you can use included columns. You can't do that with a constraint, but you can do that with an index, even a unique index. So that way you can have those columns available to you for if you need them for whatever performance reasons that your queries want. So as I was showing before, we now have an alternate key on those 4 columns on my table, so I can now support the uniqueness of those 4 columns, even though I need to use a surrogate primary key. Even in my sample databases, I actually do tend to use an identity column as my primary key, and then I'll put a unique constraint on columns like this so I can create the alternate key. I think I got in the habit because I worked at a place software company, and the way that the third-party data layer worked is it required a surrogate primary key. So I think that's why, again, I can't say they're bad, but you got to implement them properly. So entity integrity. Again, we're defining the relationship between the columns on the table and, whoops, I'm not sure what I meant by the tables themselves. That may have been left over. But it is talking about the columns on the tables. Oh, tables themselves, right. So we're talking about whether something is a fact table, whether something is a dimension table. We're talking about, primary key relationships. So a third normal form, how tables are related to each other in third normal forms. So we're starting to create that database design layout. And then we're also starting to create that clear definition of what each record is about. Because now that we've defined what our table is, now that we've defined what makes each record unique, that's starting to create the definition of what each record is about. So again, we're starting to build integrity that way. So let's see. Any questions at this point?
Looks like there are no questions so far.
All right. So let's keep going. So let's talk referential integrity. This one should be pretty short because we're going to talk about our friend, the foreign key constraint, right? There are different ones. I think if you use graph databases, there's another type of an edge constraint as well, but we're going to focus on foreign key constraints, which are the relationship between two tables. So they're great because they ensure that the value in the referencing column or the referencing column matches what's in the referenced column. It's really hard to say those that way. So parent and child, making sure the child matches what's in the parent. We've got the ability to define actions that occur when you change when the reference column is changed or the rows removed. Because remember, when you delete a record, we don't just delete a field, a column, we delete the entire record. So now we have to know how to handle it when something's referencing that column. So quick example of our foreign keys. So right now we have our gadget order form, and now we can see we have more of the relationship built out. So I now have a person table, I have a corporation table, and a gadget table. And so this is where we can start thinking about data integrity between the two tables. So that delete is a really interesting issue. And so again, we're thinking about how it means for integrity. How do we maintain integrity? What do we do with our order form if, let's say, we no longer have that gadget? Do we set the value to null? Do we have a gadget no longer exist default in our gadget table? Do we delete the gadget order record altogether or set it null? I mean, what do we do with this and make sure that what we have right now for our gadget order form is still complete? But maybe the other question is maybe we're looking at it wrong. Maybe we need to modify our gadget table so we can allow for a discontinued column. So that way we can still say we had an order for this gadget, it just no longer exists. So we can still maintain the integrity. I think a lot of times when we talk about integrity between foreign keys, we tend to think about the child record and maybe forget that, no, maybe we want to change the parent table and handle it on that end. So it's really understanding where we need to keep the integrity of our data. How do we ensure that when data changes, we can keep the integrity throughout? So now we're starting to think a little bit about the life cycle with that, because again, what happens when there's changes and we've already defined the relationship between the tables? So, and that's how we start thinking about the integrity for referential integrity. So one, we're ensuring that data is related to other tables, and we're making sure that data is valid. And now we're starting to implement rules for handling changes with those reference columns so we can maintain the integrity. So now, again, we're starting to think about that life cycle. And I think that's kind of a cool way to think about it, not something that we commonly do. So now we'll talk about domain integrity. So now we're looking at what do we do to make sure our columns create that integrity on the column level. So we're going to start with data types. And again, this is not something that when you look up domain integrity, you're not really going to find data types here listed. It's not a traditional thing. But again, it's the first thing that we do to maintain our data is good and make sure that it stays good, because that's really the whole point, right? So we need to set the type of data we're dealing with. We kind of can create constraints on the data that goes inside the attribute. So think about it. If you have a date that you need to store, setting your date type is really going to start creating those constraints, whether it's just the date, whether you're using a small date time, whether you're using date time with the date time offset. So you can now start storing the offsets with and kind of dealing with UTC dates and having to go through all of those sort of things. But it's also making sure that those dates that you're putting in there is valid. It's not just the size of the date, but if we wanted to say that it was I don't know, it was, let's see, March 452. It's, I don't know if it technically would be March 452, 2020. Quarantine's kind of lifting, but that's still not a valid date, but we can't put it in there. It also does things like preventing typos where 2020 or 2021 and you leave off the last digit, 202. Can't do that in a date time field. So we're creating those constraints to really help make sure it's valid. And so we can guarantee that whatever's in there, that data is going to be valid, or at least valid within the constraints of the data type that we have. So let's start building out on our gadget order form and start seeing a little bit more here. I'm adding a couple different other information and a couple new tables to the mix. But the great thing is we can also look at our data types and sit there and ask questions. Is this the right data type? As you can see, I told you I did a lot of integers and identity columns for my surrogate primary keys. And you can see stuff like I'm doing money for the order form, and money defaults to 19.4. So I've got 4 decimal places. This is things where I can ask myself, well, does 4 decimal make sense when I'm talking about an order form? Because if I was dealing with, stock market or gas prices, we may need like 4 decimal places. But if we're dealing with a typical sale, do we need 4 decimal places for, let's say, tax in US dollars? Probably not. We'll probably never use those extra 2 decimal points. So do we need to save that in our data type? Do we need to even try storing it? Does it make sense? Even stuff like over here on the gadget table, I have a description. Varchar 254. That's a awfully odd number for that. But yeah, I can sit and say, well, how big should my description be? Is 254 correct? Was that for a typo? 255 is a common one we'll see because of the way applications end up being coded. Is that too small for our description? Do we need more space? Where is this description going to be used? So it's really making sure that we're sizing things right so we can make sure that we can hold the data we need to hold and really make sure it works properly. I'm going to take a quick break to see any questions before I move on to the next.
No questions, although Anders mentions that we had one system where the word Anders was a valid date. Failed when loaded from COBOL to SQL. So there's a lot of pain I don't want to get into.
But that's an awesome story.
This used to be an afterthought for me. After learning more from this group, leveraging data types has become something I consider a lot, especially unnecessary conversions.
Yeah, that's a big one. That's actually a whole other. There are people who have hour-long sessions just on data types and why you want to choose those. And yeah, those implicit conversions will get you. I was actually just dealing with that a couple months ago where I had to deal with. But that's where it also gets into some of the performance issues. But yeah, just dealing with making data types really matter. So yeah, you start learning the importance of those. All right.
Yeah, definitely.
So where do we go from here? So now we're going to start talking about not null. So null is the absence of a value, right? So it says whether your column must have a value or not. And remember, an empty string is not the same as a null. I'm sure a lot of us know that. The one thing I always find interesting is sometimes null is considered a constraint. And the first time someone listed null or not null as a constraint, I kind of stopped and said, is it really a constraint? Well, I guess it is because we are putting a constraint on the column. We're putting a definition. It's just, is it there or is it not? So I always found that interesting, but I'll buy it as a constraint if you want to call it one. So looking at our diagram, I'm now showing you what I put for not null columns and null columns. The interesting thing I will point out, because we talked about what makes our gadget order form unique, I said it was order date, person ID, corporation, and gadget. Notice that I want you to be able to buy a gadget, but not necessarily buy it for your company. Sometimes we go to an event, but we don't want to do it on the put it on the company dime. We just want them to reimburse it, but we want to go as ourselves. So it's kind of that idea. So it also means it's a really good thing that we had a surrogate primary key, because otherwise I would not be able to add this because I don't have a corporation here. I'm allowing that field to be null. So it's an interesting thing that we also have to consider when we talk about going back up to some of the more basic things like unique constraints or primary key constraints, because we need to consider whether that field legitimately could not have a value that we need to have, and we need to take that into account. So not null constraints. So where do we go from here? Next, let's talk about our default constraint. So default constraints I find are kind of funny. What they do is they set the value for a column if the value for a column is not specified upon insert. If you are doing an insert and you specify a value as null, that is what SQL Server will use. Because you said something specifically for the column. If you didn't say anything, it would take the default. And if you think about it, default's only used in two cases: when you do an insert statement, or if you're doing a foreign key with set default. So you're doing a cascading foreign key. I don't think it gets used any other time. There's actually a conversation on Twitter a couple months ago where someone was asking about this, and it's pretty much, is it really a constraint? And I haven't been able to go back and find it. My Twitter search kung fu is just not great right now, but it was a really interesting conversation, because really, what is a default constraint? It's just used in these two areas. But what I do think is kind of cool, if you want to think about how it relates to data integrity, and maybe stretching it, but I think it's an interesting thing to think about, is it starts putting away in your database to define the beginning point of a life cycle of your data. Think about a status. Maybe you have a status of 0. This is a brand new record. And how your data changes, how it moves. Your starting point is here. And it can be changed. If you have a cascading foreign key, the fact that you want to go back to initial status if you no longer have referenced data that it references. I think there's an interesting way of defining that starting point for your data through a default constraint. It doesn't make sense for all of your columns, but when it does, it provides an interesting perspective on your data. We think about is active. A lot of us will have like the is active record or is active column for our tables. What if your is active by default was 0? We usually think of it as 1, because normally when we put a record into a table, we think of it as an active record. But what does it mean for your table if your is active default is 0? It's an interesting perspective. It kind of changes what that means and what your data means and what it means by inserting data where it automatically isn't active. So from that perspective, I'm like, wow, that's kind of fascinating. In a practical sense, does it mean much? I don't know, but it's an interesting way to look at our default constraints in a way that maybe we haven't before. So just something to think about. Next comes our check constraint. So the check constraint creates the restrictions on the data that goes into our column. So now we're saying we're a data type in the sense where we say it just has to be a valid date, if we have a date time data type. Now we're trying to create a range of things. So now we're ensuring the data matches that criteria. So it's a little more restrictive, and we have a little more enforcement of what we define as good data, or the range of good data for our data in that particular column. So normally we create a check constraint on an individual column. As I was looking this up, I actually discovered that you could actually create a table level check constraint, which is kind of cool. This is in the Microsoft documentation. I have the link in the resource section here too. But essentially, you can do multiple columns and check all of those at once. So like the example I saw was if you have an address, being able to use state and zip code for as some sort of check constraint combined to see if it's a valid address, if you're talking a US address. It's kind of cool that you have that sort of extensibility too. I've never had to use a table level check constraint. I didn't even know they existed until a couple months ago, but I think it's a cool enough thing to know that it exists that I'm mentioning it here. So domain integrity, what does it do? We're defining the type of data to expect for each column. We're ensuring the data in the column matches what should be there. And even just the basic, saying whether the field is required to have a value. Excuse me. All right. Any questions on this?
No questions so far.
All right. So now let's get to the heart of it. Let's talk. Whoops. The other thing for. Whoops. We just went over this domain integrity. There's even more to domain integrity that I meant to talk about. Sorry about that. The idea of the default constraint, common known value, but really it's this last key point here. Eliminates ways for bad data to get into our tables. That's really kind of the key of all this domain integrity that we're talking about. We want to make sure our data is good to begin with. So now we can talk about data integrity and performance. So they two go in hand in hand, but we often don't think about the benefits of data integrity, or sometimes certain ones we do think about. You don't want to have too many records, so making sure you have unique records, keeping out duplicates so you don't have to deal with it in your code. That's a good thing. But there are kind of couple other things that we deal with in performance, and it's also in how SQL Server uses it too. But the first one I want to talk about is a clustered index. So I'm going to bring up the idea. Is a clustered index about integrity or performance? So thinking about what a clustered index does, it defines the order of how the data in the table is physically stored. So is that integrity or is that performance? I'm going to argue it's performance. It's not about the integrity, because the clustered index is about that physical storage. And remember I said where we start talking about this sort of thing, certain things get very logical, certain things are physical. The clustering is really the physical implementation of where the data is stored. It doesn't change the fact that whether you need to do your primary keys don't have to be clustered. Let me start with that example. So we tend to cluster them because, again, we tend to use surrogate primary keys. It's an identity column. It's nicely ordered. We don't have to deal with page splits or anything like that. But again, if you think about it, it doesn't define your table the same way a unique constraint would. Now, you can cluster a unique index, so it could be the clustering could be there, but again, it's about how you're physically storing it and not really what's defining your table. The fact that your data is ordered, not necessarily the same as what your table means. Because of where you can put the clustered index can change, I would say it's really about improving your performance and not about defining the integrity. But there are also cool things about integrity that the query optimizer is going to use. It can use not nulls. It can use those primary key constraints, those unique keys, the foreign keys, check constraint. Pretty much anything that we put the word constraint next to, except for default, the query optimizer can actually use, and we can see how it'll make decisions based on that in our execution plans. And of course, data types. We were kind of touching upon this earlier. Talk about database, your size of your database and how much memory you have to do, because remember, we got to figure out how much data we're pulling back, how it's going to be held. Now we have to deal with memory grants for the queries to make sure that we can hold all of that, and how does everything get put together. And we started touching base on that idea of implicit conversions and what that does for performance, and how that can actually prevent things from, like your index, which indexes are definitely more for performance than enforcing your integrity, just your average non-clustered index. But if your data type is wrong, you may set things up so we can't use those indexes, so you can't get those performance gains. So I have a couple demos we can talk through and we can kind of reinforce those ideas. Any questions before that? I grab water.
So far, there have been no questions.
All right. So I've got my execution plans on. So let's talk about some of those constraints and just get some basic examples so we can see how everything's being used. So this first one, we're going to talk about null and not nulls. So I've got two queries here. So my first query, the key that we really care about is right here. Our shipping column is not null. And then we're going to do a similar query, same query, shipping is null. So I'm going to run both of these side by side. And we're going to go look at the execution plan. And we can notice the first one here, we notice it's actually doing work. It's doing what we'd expect it to do by putting things together. The detail's not too important right now. But what's really important is down here. Let me see if I can zoom in, where I'm saying is not null, or where the column is null. So the column I'm doing the query on is a not null field. So SQL Server kind of looked at the query, said, you want me to find out where this column is null. Can't happen. Sorry, I'm done. Bye. And it does a scan, and it knows that nothing can be returned. So it doesn't do anything. It bypasses everything. So nice, quick, and easy. So now let's start looking at the primary key. So same query, and I'm going to do a search on my person and my person ID. And my person ID is my primary key constraint. So I can run the query. And as we look at the execution plan, we can look here at our index seek. And if we look at a couple things, let me see if I can zoom in enough. Where'd it go? We can see stuff like the number of executions or the estimated number of rows. Well, I'm doing this on a primary key. Our primary key has to be unique. It knows it can only be one. So it already knows that it can figure out the right number. My estimated is 1. It can already figure that out. So that's nice and simple. So unique constraints are a fun one because it's kind of something similar. So we can kind of get a better idea of those back and forth with things. So I'm in a database called Superheroes. So let's create a villain schema with our not so nice database schemas. So I have one here. I'm creating a villain equipment table, and I'm going to populate it from my gadget table, and I'm going to add a null. So we're going to put a null in here. So when I look for that first null column, notice I don't have my unique constraint yet. I go to my execution plan, and we can see I'm doing a clustered index scan. And I mean, luckily this is not a large table, but think about if, you had hundreds of thousands of records in here. It's estimating that it's going to go through all 34 records. But we know we want this to be unique, so let's take a look. Let's add our unique constraint. And now we can run our statement again. We look at our execution plan, and it's definitely changed a lot from what we saw before because we're automatically getting that index seek. And we know it's only going to find one, and it's done. Nice and simple, right? Because even the estimated number of rows, it's unique. It knows there can only be one. These are pretty simple examples, but you can really see that with these, that SQL Server is figuring these things out. We can do the same thing. We can test it up instead of looking for equipment name. We can, we can put in actual value, and we're going to see the same thing. I was actually just looking for null. So even searching for a null value, it's already figuring out that the null can only exist one time because I have a null and a unique constraint. So we're done with that table. So let's talk foreign keys. So I have this table here, or this query here, using my villain schema, my villain gadget order form. And I'm looking at my query, and we can see I'm doing an index scan nested loop. If I look at estimates, it's looking through all the numbers. Not much exciting here, but I'm going to do something here. I'm going to take out the names, right? Because I'm joining from two fields or two tables. I'm looking at my Villain gadget order form, and then I'm looking at my person, joining that to my person table. I'm going to edit out my person table, and I'm just going to use my Villain gadget order form. I'm still going to leave the join there, but SQL Server has a way of saying, hey, I don't need to use something if it realizes it's not being used in a query. So it's usually smart enough to figure these things out. And if we run that, so we're not even pulling any columns from our person table. I did comment those out. No, I didn't. Let's try this again. Following my directions. So I'm only pulling out two things. I'm no longer looking at anything from my person table, but it's still there. SQL Server hasn't figured out that I'm not using those two columns. So let's look at this a little bit further. So now I'm going to add my foreign key constraint, because this is how SQL Server is going to figure things out, right? I've got to join to my person table. And because I've got my foreign key in place, SQL Server can now be smart about how it takes its execution plan. It can say, I have a foreign key, so I don't need this anymore. So let's run. So we can see the foreign keys there if we wanted, but let's go back and let's rerun this again. Same query, formatted slightly different, but again, I'm not using anything from person. I've got my foreign key in place. SQL Server is totally going to figure this out, right? When we look at the execution plan. It's still there. Now, there are blog posts by Grant Fritchie and Hugo Cornelis talking about this. And if there's two people that I trust so much about execution plans and how SQL Server works and puts these together, those are two people on the top of my list that I'm going to test as references. So why didn't this work? This one took me a while when I was first putting these samples together. Could my column be null? If I look at my person ID, why, yes, it is null. That's the key. So I'm doing a join between, the inner join between gadget order and person. So essentially, this is my where clause. But because SQL Server, I've got a foreign key there, but SQL Server doesn't know if how to handle nulls. Well, actually, it has to filter out nulls because an inner join says they have to exist. So because it's a nullable field, SQL Server doesn't know, and it has to include the column that we didn't think it should, or include the table it didn't think it needed to. So let's make our column not null. And now let's run our query again. Again, keeping everything the same query we're running up here. And when I check my execution plan, we can now see that it's only dealing gadget order form. So it's not just the foreign key that made SQL Server say, hey, I don't need this table. I can just pretend it does. I don't even need to include it in my execution plan. It's the not null for an inner join that said, hey, I don't need to include it there either. So it was interesting for me to actually find that it's the null that made the difference in a foreign key constraint. So all of those things together really matter if we want to talk about how do we create data integrity and data integrity that we can use for performance gains. So I'm going to reset my tables to its villainous self. And now I'm going to do a similar one with check constraints. This is pretty similar to what we were talking about before. So again, I've got my check constraint. And if we look closer, we can say that I want number ordered between 0 and 10,000. So you can't order a million of something, but you can order 10,000 gadgets. Seems reasonable to me. So now I'm going to do a first select here where I'm going to look for anything where we've ordered 4. And if I look at my execution plan, it kind of looks how I'd expect it to look. It's joining between everything. It's figuring things out. All right, nothing exciting here. And then just to prove the point, let's look when we have numbers ordered 10,001. So just one over what we set the limit to. nothing returned. Execution plan, hey, same thing as it did for a not null, looking for a null on a not null field. It says, hey, I know this can't exist, so I'm done, bye. So again, a quick way that SQL Server can be smart about using its constraints for coming up with execution plans. So we're talking about data types and implicit conversions. So we have a couple things in our villain schema. And so we've got a couple orders that we want to put in here, or that we want to look at. So I'm looking gadget order form, my person, I've got a villain gadget, and I'm throwing corporation in here for fun. So if I look at things, we can look at our data and we can already start asking questions. And this is why I always like to say, hey, let's really make sure that we've got, understand our data well, because we can see stuff like these first 3 rows here. I see a lasso of truth 3 times, and everything about it, as far as I can tell, even down to the order date, looks the same. So you can probably guess that I call this the villain schema because I don't have anything that makes it unique. So if I were to return a lasso of truth, and because I only wanted 1 then 2, well, which order does it go to? Were these duplicates? Do I actually have 6 lassos of truth? That'd be amazing, but probably sadly not true. But it's one of those things to kind of think about with our data. So if I were to run the same thing in our DBO schema, we can kind of see these things here too. We can see it's much cleaner. So I wanted to show data first, but let's actually run these two together and kind of see a little bit more. Actually, let's go back to this one because there's a couple things we wanted to talk about. We were supposed to talk about implicit conversions and some data type stuff. We can notice stuff here in our select statement. We've got, if we come here, we can notice that we've got the warning sign. And we can start seeing things like implicit conversions, our gadget ID. It wasn't an integer, but I'm using an adjoin criteria to a varchar field, or one of them is a varchar field I'm converting to an integer. And the thing that this kind of does is we can see other things that come about from this. Things, if we were to, let's see, in our properties, I think we could see, I think we were seeing, I'm on 2019, so things may have changed on me if we were to look at my properties here. But we can also sometimes see that the implicit conversion can do weird things to like memory grant info. And we can say that, well, this has only been run once, but we can start saying, we can see where different scans or different things like compute scalars, because we're having to do changes for implicit conversions. So things start getting a little more complicated. So if I did this with, compared to the one where we have a nice clean schema where I have unique indexes and I'm pulling out just the right data, we can see changes where here we were seeing a compute scalar between our order form and our join. Well, we don't have that anymore because, again, that we're having to figure out how to convert things, how to change things over. And so we can do those matches. So we're making SQL Server do a lot more work for a more complicated thing just because our data are mismatched. And we can start saying that, looking at different ways that if we have something that we consider a clean version, how it may work when it's not so clean. I have a table scan because I'm missing an index, which is always fun. This is a villain. Yep, it's a villain one, right? So again, it's kind of looking at how these different things play about, because again, if my gadget order to gadget, table scans, hash match, versus here, I can do a nice nested loop because it can figure out much better what it needs to do, what data is being pulled back, and it can come up with a much cleaner, nicer cost. Just a couple things to kind of look at. If I added a primary key, we can start seeing different things for performance. So I tested this in a different version, and I'm noticing my 2019 instance has updated things and running things weird. And at one point, I was getting a hash match with this between the two because of that implicit conversion. My 2019 instance is showing things a little differently today. But again, we can open things, and we can, even if we wanted to, we could run something, look at it in Plan Explorer, and really find other ways in our query that we're getting different results and such. But these are just kind of small ways that we can start looking at the implication of our index, not indexes, our constraints, making sure we have the right constraints, making sure we have the right data types, and we can start looking them in our execution plans and really see where SQL Server starts using them and how it can start using them not as nice ways depending on when you run them, what your machine is, how much data you're doing, and you can really start feeling the impact of that. Any questions?
No questions here. Andrew said this was about the best description of why the left outer, or excuse me, the inner join where the column is nullable doesn't cause elimination. Great explanation of that.
Thank you. Like I said, when I was first putting these demos together, I was having trouble figuring that one out. I'm like, but Grant and Hugo set, and then once I had that null, it was like a little light bulb went over my head. So I'm glad that worked for you too. I'm glad it made sense.
And looks like no questions.
All right. Well, those are the demos that I wanted to show you. So I kind of wanted to leave y'all with some parting thoughts on this. And this is the big one. Is data integrity 100% achievable? Now that we've kind of talked about all the different ways that we try to put things together, can we 100% get a perfect data with great integrity, all of those sort of fun things, right? No. It pains me to say it, but I just don't think it's 100% achievable. I think it's a fantastic goal, and I think it's really one we should be worthwhile. We should really try to go for it. It's totally worthwhile because while we try to create it, it helps us understand our data and how we work with it and what we need to know to make it as clean as possible. People are like, oh, we'll just clean this up in the application. It's like, well, you're still doing bad data, so you're having to do more work. And so for me, if it's doesn't matter how great your app code is, it could be the best app code in the world. If you're dealing with bad data and poorly designed data and there's no attempts at integrity at all, your app is going to have to do more work. And so it's not going to be as great as it should be. So it's helping figuring out what we can do on our end as data professionals to put those little pieces in place so we can try to get there as much as possible. And we can see where we get those advantages. But, real world data is just messy. Like, I wish it weren't, but it's just messy. So it's really doing what we can with that to try to clean it up as much as possible and do what we can to put those things in place to kind of help things along in that sense. So it all gets back to making sure that this one means one. By the way, anyone curious as to what this is? I thought I'd add this as a little Easter egg. So what is this one? So it was this query, and it's the number of royal tiaras that I've ordered for myself because I thought it would be fun. Yeah, I'm cheesy that way. So, but again, it's making sure that the idea is the number ordered is the actual number ordered. So whatever it is, we want to make sure that one stays representative of the number of tiaras I've ordered in that particular time. So thank you all so much for coming. So as I said, I had a whole bunch of references for you. So talking about the unique constraints and check constraints. So if you're curious about table level constraints, you can look there. Kendra's article about unique constraints versus unique indexes. I had a little blog post about how I really feel about surrogate primary keys, a lot of which I already shared with you earlier. Some references to Grant's article about foreign keys and performances and where they can and can't help performances. It's a different article for you. And I just want to say thank you all so much for coming. Thank you so much for having me. And I hope that there's, again, I know a lot of these are the basic building blocks of what we do, but I hope it's a different appreciation for how they all work together and just kind of thinking about how we can do a little bit more to put a little more integrity into our databases. So any other questions?
It looks like no questions, but you're getting awesome presentation. Thank you. Excellent presentation. This was great. Great presentation. I agree. It was a great presentation.
Well, thank you all so much. And I have my contact information here. So if you do find you have questions or you wanted to talk more about this, please hit me up. I do have a GitHub link and I will put these slides up there later. So they will be available, and the demo script is also up there as well.
Excellent. So
yeah.
with that, we are going to wrap up for tonight. Next Monday, we'll have Shop Talk. Next Tuesday will be our data science and business intelligence meetup, where we're going to have Josh Higginbotham talk about functional ETL with Python. So stop on by for those next week. And until we see you again, everybody, have a great evening.